Welcome to Azure Data Explorer Shorts. I'm Vincent with the Azure Data Explorer team. Today we talk about update policy patterns. This is a follow-up to update policy introduction, which I invite you to look at. A quick recap: an update policy is something we define on a table to take data from another table and transform it when data is ingested in the source table. And now we're going to look at usage patterns. So what pattern can we implement using an update policy? What things we typically see? The first one we're going to look at is transformation. So this is when we have a source table and destination table. And very often we have data such as JSON data or some type of encoded data here, pipe delimited data. It could be any type of data you want to extract or pass from the original data and put it in the destination table in a more structured, meaning rows and columns way. And this is a bit the example we saw last time where we parse the input row containing an error message and an error code and we parse it. So this is transformation. We then have enrichment, is when we take the data in the source table and want to add information, not only transforming it, but we add information. Maybe it comes from an external system such as Customized DB or SQL database, and we want to, for instance, take a lookup table and replace the value, or it could come from Azure Data Explorer Custo table. Actually, let's look at an example of that. So here I have the same database I have last time. So I have my logs table, and I have my structure logs, which gets transformed into a more structured data. I'm going to create another table called error codes, and I'm going to throw a couple of error codes in there. If we look at that table now, so it's a bunch of error codes that basically encode a lookup table. So I could now define a function that enrich the my structure logs. Remember, my structure logs is this one. I could do a lookup on the error code and enrich it with the error code name. And this is what we do here. So I define a stored function to do that. And if I look at the current data, that's exactly what it does. So I basically enrich the table with the error code name. Now, if I want to use that as an update policy, I would need to define another table. And this is what I will do here. And I'll give you a trick. When you don't want to spend your life typing schema, something you can do is use the output of a function to define a schema. So here I'm going to define table and I'm going to set it. So I'm going to logs function and I'm going to do a limit 0. So I'm going to take 0 row, but I'm going to extract the schema out of it. And now if I look at this, I have the right schema in this table. I'm going to then define the update policy, the source being my structure logs, the query being enrich structure logs, so this function over here, and of course being transactional. Define this, and then I'm going to insert some data in the original table. So in my logs, I have an update policy that will push it into my structure logs, and this latest update policy will push it into my enrich logs. So I push 42, and you can see there's 3 extents, so 1 extent for each table. So if I look at my logs, the last line is with this 42. If I look at my structure logs, I have this 42 where I pass the text, and my enrich logs, I got the syntax error code name that was enriched. So this is enrichment, where we take data from elsewhere than the source table and we enrich it to push it to the destination table. Another pattern we're going to look at is routing. So routing is when you have a source table and you have many destination table. Here I give an example of an event type. So maybe I have some IoT data getting ingested in my source table and I want to have it pushed to different tables depending on an event type, column, or property. And I'll do that with then 3 update policies, applying some filtering on the source table. This is especially useful if the schema of the 3 tables on the right-hand side are different. You can have strong type data in each of your table. I would advise against going nuts with that and routing to 100 different tables just for the sake of filtering, because that's going to consume a lot of resource. Each time you insert something in the source table, you fire a bunch of queries on different tables. So I would advise against going too far with it. It's very useful in many scenarios. The last pattern we're going to look at is staging. So it's basically combining the previous patterns that we looked at, just to mention that this is very typically done on complex scenarios where you have a landing table where you ingest your raw data coming from event hub or blobs, or logstash, or whomever, you transform it into a first staging table. So you transform, or maybe you parse your data, then you enrich it to drop it into another staging table, and finally you route it into the final table. And I've seen scenarios more complicated than that where you have many stages like that. We draw a comparison last time with ETL, extract, transform, load. You have the same thing with update policies. Why would you do it that way? Because it's easier to debug. It's just easier to look at and monitor and replay, that type of thing. So we look at different patterns that we can implement using update policies. Really, sky's the limit. It's just your imagination that limits you, but we show you the usual patterns that we see, or the most popular ones. If you have any questions or comments, please leave them down below. Otherwise, as usual, follow us on different social media. And until next time.